All right, we are ready. We are live, and let's see what's up, guys. So, Note 7 transformations. For the record, we will have an exam next week. Did I already tell you guys that? Okay, it's over. It's on Canvas, but just in case, this question that we put here well, the topic today, the learning objective today is transformations, right? Transformations of sinusoids. And I know you're probably looking at the very beginning and you're like, those aren't sinusoids. But it's the properties, and I wanted to make sure that we are pretty good with properties. This question is from the 1970s, so this was an actual calculus exam. So maybe your parents, or I don't know, maybe they weren't even born yet. Maybe your grandparents took this test here. So let's just get right into it. I'm going to highlight some points. This is a graph we're going to be referencing over and over again. So what points am I going to highlight? So -3, -3, -2, -2, -1, -1. I'm saying ordered pairs. 0, -1, 1, 0, 2, 1, and 3, 0. So I'm going to reference it over here on the left. F of -3 equals -3. F of -2 equals -2. F of -1 equals -1. F of 0 equals -1. F of 1 equals 0. F of 2 equals 1. F of 3 equals 0. And I'll make a table so you can see all the different ways we can grab this information here. -3, -2, -1, 0, 1, 2, 3. -3, -3, -2, -2, -1, -1, 0, -1, 1, 0, 2, 1, 3, 0. And of course, this point here, I'll reference this point. That point is 2, 1. So you can say that is f of 2 equals 1, or you can also say that guy is that guy. See? Sorry, I laugh because right now we're looking at monitors. 100 years from now, we'll probably all just have like virtual reality headbands, and we'll just be like just looking at it, and who knows? Maybe we don't even need to be writing. We'll just be like uploading it to our brains or something. All right. How do we feel? Nothing crazy, right? Pretty simple, pretty straightforward. Does everyone know where we got these values? Yeah, they're all referenced from the graph itself. So we come down here, notice what they want. They're telling me that my new y values, I guess I don't have to put the word new, I can just say transformations, right? My new y values come from the absolute value of f of x. So I'm going to come over here, I'm going to go x, and I'm going to go absolute value of f of x. So these are going to be my new values. So I'm going to start -3, -2, -1, 0, 1, 2, 3. I'm going to go slow. Let me see. Can I see it all? I'll start right here so I can see this. So this means, let's see, what does this mean? Absolute value of f of -3. Well, f of -3 was -3, see? So absolute value of -3 is just 3. So go to -3 and then 3 and then point. Absolute value of f of -2. That was just, according to this, was just -2. Absolute value of -2 is 2, so -2, 2. Do we see what we're doing, guys? Okay. Absolute value of f of -1. That is just absolute value of -1, which is 1. -1, 1. Absolute value of f of 0. F of 0 was -1, so absolute value of -1 is again 1, so 0, 1 point. Absolute value of f of 1. F of 1 was 0, and absolute value of 0 is 0 anyway, so 1, 0. absolute value of f of 2. Well, f of 2 was already positive, positive 1, which is still just 1, so 2, 1. And then absolute value of f of 3, which is just absolute value of 0, which is just 0. All right, connect them. What happened? What happened? Look at the original and look at this one, and what happened? What happened? You don't have to be formal. Just look at it and be like, oh, all the y values that were turned positive. Well, not okay. Yeah, yes. Can we be more specific? Because I can say -3 and then +1, but that's not right. Like I didn't have a y value of -3 that turned to a +1. See, that's negative turned to a positive. Let's be better. Yeah, I'm gonna say everything below the x-axis got reflected. I don't know if that's proper English. Everything below the x-axis got reflected across the x-axis. So everything that was, and there it is. And then if you were above the x-axis, it was left unchanged. Does that make sense, guys? Yeah, there it is. We're done. We're done. Let's go to the next one. Letter B. I'm going to make a table. Oh, chop. This one says absolute value of x, and that's inside f of x. Yeah. -3, -2, -1, 0, 1, 2, 3. Let's see. F, open parenthesis, absolute value of -3. Well, that's absolute value of -3 is 3, so that's f of 3. Well, f of 3, I think that was a 0. Let's see. F of 3 is 0. See? So I'm going to put 0. So -3, 0 points. F, absolute value of -2, close, open, equals f of 2. F of 2 is 1. So this equals 1. So -2, 1 point. Does everyone see what we're doing? Yeah, look, I'm going to do another again. Ready? This is f absolute value of x, right? So I go f, open parenthesis, absolute value of -1. Close the little absolute value sign here. Close. What's absolute value of -1? 1. So that's f of 1. I come over here and I look at what f of 1 is. F of 1 is, so I come back, equals 0. So -1, 0. You guys see what we're doing? F, open parenthesis, absolute value of 0, close, or close absolute value, close the parenthesis. This is f of 0. Oh, that's unchanged, -1. So 0, -1. And then these are going to be the same because absolute value of 1 is 1, absolute value of 2 is 2, absolute value of 3 is 3. So f, open parenthesis, absolute value of 1, that's just f of 1, see? So f of 1 was 0, so 1, 0. So this is going to be f of 2. F of 2 was 1, so 2, 1. And this is going to be f of 3. F of 3 was 0. I'm looking it up there. So 2, 2, 2, 2. What happened? Let me zoom out. Can I see the original? There we go. I can barely see the original way out there. What seems to be the difference? Yeah, it's symmetrical about the what axis? Y-axis. Everything to the left of y-axis got deleted, and then got everything that was to the right of the y-axis got mirrored across the y-axis. Do you guys see that? So that's what I'm going to say. I'm going to say Everything to the left of the y-axis, everything left of y-axis was deleted, period. And then I'm going to say everything to the right, and I'm going to open up a parenthesis, quadrant 1 and 4, and then close parenthesis, was mirrored. How do I spell mirrored? O-R-E-D. Mirrored across what axis? Y-axis. I was going to say reflect, but I think mirrored is a better word because it's symmetric. When you look into a mirror, you see yourself and your image. So it's the same thing here. Kind of. Symbolism. Who says we don't have symbolism in math? Now this is English class. No, I'll stop. For you guys that are in the one act play, like how do you demonstrate horror or that someone's like, do you just put the lighting to red or something, or lighting's red, he must, okay, I'll stop. LOL. Okay. Next one, it says negative x. So here we go. X comma f of negative x. All that just means is change the sign, opposite, right? If it's positive, it's now negative. If it's negative, it's now positive. So we'll show the first one, and then we'll just do the rest. Negative 3, negative 2, negative 1, 0, 1, 2, 3. So let's see. F of negative, parenthesis, negative 3, close. Negative times a negative is a positive. F of 3 was 0. So negative 3, 0. So this turns to f of 2. F of 2, I believe, was 1. So negative 2, 1. This was f of 1. I believe f of 1 was 0. Negative 1, 0. Let me check. F of 1, 0. Yep. This one doesn't change. This one stays as f of 0. So negative 1. So 0, negative 1. This is going to turn to f of negative 1, because it says negative x there. So f of negative 1 was negative 1. So 1, negative 1 point. This is going to turn to f of negative 2. So negative 2. So 2, negative 2. This is going to turn to f of negative 3. So negative 3. So 3, negative 3. What happened? Yep. Flipped across y-axis. Yay. Oh, okay. Oh, that's probably one of my worst smileys. All right, let's go to the next one. What do you think is going to happen on this one? Do you remember from your Algebra 2 days? Horizontal stretch or compress? Stretch by what factor? Yeah, you remembered. Good job. Can you tell me why? Because what? Tell me why. Or are you a robot? No, you're not a robot. You know. Oh, you might be a robot. It's stretched. It's a horizontal stretch by a factor of 2. Let me tell you why. What is half of negative 6? Yeah, negative 3. So look, 1/2 times negative 6. So this looks like f of negative 3, and f of negative 3 is negative 3. So I'm going to go to negative 6, and I'm going to put a point at negative 6, 3. Excuse me. What is half of negative 4? Negative 2. So I'm going to go to negative 4, and I'm going to plot the y value of negative 2. You can already see what's happening, hopefully. Half of negative 2, and at negative 1, it was negative 1, so negative 2, negative 1, point. This one's unaffected. Half times 0 is still 0, so negative 1. That's what the value there was. What's half of 2? 1. And f of 1 was 0, so 2, 0. Half of 4? 2. And f of 2 was 1. 4, 1. And half of 6? 3. And f of 3 was 0, so 6, 0. Look at what happened. There was a horizontal stretch by a factor of 2. You can see if you were to pull on the x-axis, the original image would start looking like this if you did a horizontal stretch by a scale factor of 2. And so the question is, why does it do a horizontal stretch by a factor of 2? Well, I have this 1/2 on the inside, and whenever you take this x value and you multiply it by a half, you get the values that were on the original. So if you go in reverse, you have to multiply by 2. Does that make sense? Maybe, let me see, did I say that right? So if we wanted to find our original x values, you take, if you wanted to find your new y values, you take your original x values and you multiply it by 2. So this point right here, negative 3, you multiply it by 2, and you're going to be at, well, that's not the original. You take this value here at negative 3, you multiply by 2, you're going to be at negative 6, but you keep the y value the same. You know what I mean? So that's how we know that. Chop, I don't understand anything you just said. So this point here, guys, is negative 3 comma negative 3. So what I'm trying to tell you, if I have this transformation, y equals half of x, well, check it out. I need to make, so this is, so I know, it might sound confusing. So this is this. If I want to make sure that I have an output, I'm going to double that negative 3. So check it out. F 1/2 times negative 6. I'm doubling that negative 3 because I want to make sure that I have this output of negative 3. Half of negative 6 is negative 3. So f of negative 3 equals, and oh, look, here it is. F of negative 3 equals negative 3. See? So notice what x value I put in. X equals negative 6. So that's how I know this is my new x value when you have this type of transformation. Did that kind of make sense? I know we're kind of rushing a little bit, but this is why you have that horizontal stretch of 2, right? These are all outputs that you have on your original. Notice every time I take this x value and I take half of it, I have that one in there. I take this x value, I take half of it, I have that one in there. You know what I mean? And now I'm plotting this, negative 4, negative 2, negative 6, negative 3, negative 2, negative 1. And note, we get this image, which is a horizontal stretch by a factor of 2. If you would have had f equals 2x, what do you think happens? Horizontal compress by a factor of, not 2, half. Half. If I would have had a 2 in there. Cool? Okay. I'm deleting that so you don't think that that's part of the notes. All right, what do you think is going to happen here on this one? Everyone has been getting this one right. It's going to move to the right one time. So because of that, I know, like Trav, we already know this. That's why we got the hack. I'm going to start at negative 2, not a negative 3. Because if I put negative 3 in there, well, you'll see right now. Negative 2, negative 1, negative 0. I can't believe I put negative 0. Negative 2, negative 1, 0, 1, 2, 3, 4. Look what happens, guys. I'm going to write f, negative 2 minus 1. Well, that is f of negative 3. F of negative 3 is is 0. It's negative 3. Man, what's wrong with me? It's been a long day. It's been a long week. All right. F of negative 1 minus 1. Negative 1 minus 1 is negative 2. Negative 2. And f of negative 2 is negative 2. f of 0 minus 1. That's f of negative 1, which is negative 1. F of 1 minus 1. That's f of 0, which is negative 1. F of 2 minus 1. That's f of 1, which is 0. F of 3 minus 1. That's f of 2, which is 1. And the last one, f of 4 minus 1. That's f of 3, which is 0. Plot the points. Negative 2, negative 3, point. Negative 1, negative 2, point. 0, negative 1, 1, negative 1, 2, 0, 3, 1, 4, 0. What did you notice? Not everyone at the same time. Yeah, it was shifted. One to the right. Did doing this help? Because I don't know, maybe for the next year's group, maybe I shouldn't talk about all these transformations and just go right to the sinusoidal. Did doing this help or no? No, for reals. Or are you just telling me that just because that's what I want to hear? For sure.
Yes.
Okay. You're not just saying that.
I'm not just saying that.
Okay. Let the record show that my kid said that it helps. So now it's going to be here forever. Because I wonder how long YouTube will last. Do you think YouTube will last for the next 200 years? So then that means, like, let's say I just leave those videos uploaded. Well, 200 years from now, will they still be there? Do you know what I mean? Like, see, like, okay. All right, and I was already starting to answer this. I better not. Okay, here we go. Let's read this first. It says, the figure below shows a quarter cycle. So a quarter cycle, 25%, of a sinusoid in degrees. Write a particular equation for the wave. Okay, 25%. So that means I either go from a high to the point of inflection in the middle, that's 25%, or from the midline to the low, that's 25%, or from the low to the midline, that's 25%, or from the midline to the high, that's 25%. Does that make sense? So what does this 8 look like? Does it look like a high, a midline, or a low? It looks like a midline. That means this 3 must be the low. And let's see, the gap is 5. So then if I go up 5, so that must be the high up here. Your graph doesn't have to be perfect. So don't try to be perfect. Are we okay so far? All right. Well, this gap here, that looks like it's 7 degrees. 24 minus 17, yeah, 7 degrees. 4, 5, 6, 7. So if I go back 7 degrees, and see, it looks like right here, that's 10 degrees, and I go from the midline to a high. I guess if I'm going right to left, I guess I should have done left to right, but that's fine. No big deal. I wanted this one. Excuse me. Cool or not cool? Okay, I'm going to go 7 degrees to the right from the 24. So I'm going to be looking at like 31. And I'm going to go to the midline because that's a low from low to the middle. There it is. I'm going to go another 7 to the right. I'm going to say like right here. I'm going to say that's 38 degrees. And that 38 degrees, I better be at a max. And there it is. I just did a whole cycle. This is 100% from peak to peak. Are we okay so far? Okay. It wants me to write a particular equation. I'm going to use cosine because cosine uses a peak. I could have used sine also. I could have used this one for sine, but I'm going to use cosine. So I'm going to write y equals a cosine open parenthesis b open parenthesis x minus c close plus d. The a. I can get the a by doing 13 minus 8 or by doing 8 minus 3. They will both give you the same number. The amplitude is 5. We're okay so far? Okay. I need to find the B. I'm in degrees, so it's going to be 360 degrees divided by the period. I'm going to come over here to the side. It does not matter how you get the period. There's so many ways to do it. If I do peak to peak, it does not have to be peak to peak. It could be min to min as well. But I don't have another min, so I'm just going to do peak to peak. 38 minus 10 degrees, so that's 28 degrees. You could have also gotten it by saying, well, this is 25% of a cycle, 7 degrees, and then multiply it by 4 to complete the cycle, and you would have gotten 28 degrees as well. Does that make sense? So I come over here and I go 360 divided by 28. I don't think it goes perfectly into it. So if I take my little calculator and I go 360 divided by 28, yeah, turn it into a fraction. And there it is, 90 over 7. So I'm going to come back and I'm going to say that's 90 over 7. Now, remember, guys, well, okay, we'll tell you in a little bit. The C, since I'm using cosine, I'm going to use the 10 degrees. 10 degrees to the right. And I'll put parentheses using cosine. So use the x value of your peak / max for good notes. And then the last, not least, but that's what everyone says, right? Last but not least. Midline is your 8. And I was going to mention something because I don't want you guys to be a robot. Check it out. And I know some of you are probably going to say, well, yeah, that's the same thing as doing 360 divided by your b, right? The period. Remember that y equals cosine x, that's your parent function. That should have a period of 360 degrees. But look at what my b value is. It's always the number in front of the x. If you were to distribute that, see, that's your horizontal dilation. Not the b itself is not the horizontal dilation, but you get it. Don't yeah, that's the mirror. That's a joke, Ms. Miller. Remember, what's your b? The b is 90 over 7. So this is so that means your scale factor, in second compression, your scale factor is 7 over 90. So if you take 7 over 90 and you multiply it by 360 degrees, that will also give you the 28 degrees. Don't believe me? Look. 7 over 90. 7 over 90. Sometimes I put the little fraction thing, but times 360. Look, guys. You get 28 degrees because it's your scale factor. I know some of you are looking at it like, well, Chav, if b equals 360 over period, then the period is just 360 over the b value, which keep, change, flip, and you'll get that anyways, times 7 over 90, keep, change, flip. It doesn't matter how you do it, guys. You'll get the right answer no matter what. You know what I mean? Like, they're all connected. All right, you already know what I'm going to do. I'm going to type it into the calculator. So take your calculator. What mode should it be in? Degree. And I'm going to go y equals on y1. Yeah, reset it because there might be a whole bunch of junk in there. You guys know how to reset? Okay. I'm going to type in, what am I going to type in? I didn't even create the equation. Y equals 5 cosine, parenthesis, 90 over 7, open parenthesis, x minus 10 degrees, close, plus 8. Type that. 5 cos alpha y equals, enter, 90 over 7. 90 over 7. X minus what? 10? Close, plus 8. Click on window. The smallest x value I have was 10. I'm going to say 0. So I'm going to put 0. My biggest x value is, let's see, 38. So I'm going to say 40. So 40. Scale, you can go by 5 or 10 or 20. Y min, it looks like, let's say 0. And then Y max, let's say 13. So let's say 16. 16. And then Y scale 1 or 2 or 5 if you want. X resolution, delta X, and trace step, leave them alone. Push graph, and there it is. Let's test it. Here we go. Trace 10. Enter 13. All right, let's see. What else do I want to test? Let's test a midline, a midpoint. I better have a point at 17, 8. So I'm going to push 17. Enter 8. Yep. Next one, let's see. 24. I'm going to push 24. 24. Enter 3. Yep, it works, guys. Cool, right? Okay. So now I'm going to go. We're done with that. Go to the next page. And we're just going to do a whole bunch of transformations with that same graph. So don't clear it. That's the same graph. Did you clear it? Same graph. So here we go. The equation we came up with. Y equals 5 cosine 90 over 7. X minus 10 degrees, close, plus 8. Are we okay? Okay. All right. Before I continue, I want to make sure that we understand. Guys, it does not matter if I use cosine or sine. Everything's going to be the same except for C. That's the only thing that's changing. The graph is the same. I have my maxes and my mins, the frequencies. It doesn't matter. It's the same wave. So everything's going to be the same for the wave. The only thing that's changing is the C. Cool? Okay. Look at what letter A wants. A phase displacement other than 10 degrees. Okay, well, if I'm using cosine, because that's what they want, give me another peak besides 10. Where do you see another peak? So that's what I'm going to write. Y equals everything the same. 5 cosine 90 over 7. X minus 38 degrees, close, plus 8. So you already know what I'm going to do. I'm going to go to Y2 on my calculator, and I'm going to type that in there. So go to Y2, and I'm going to type that in. 5 cosine alpha Y equals, enter, 90 over 7, open parenthesis, X minus 38, close, plus 8. This one's going to graph it in red. I'm going to push graph. Voila, same graph. I know if you don't have a colored calculator, I'll show you how you can see it all. So type it in just so you can make sure. Don't worry, I'll show you at the very end how you can also check, like even if you don't. All right, you guys ready? Go to the next. Let's go to the next one. Let's go back to our little thing here. It wants a sine graph. So the difference between the cosine and sine, if I'm using cosine, I use a peak. If I use sine, I got to use a what? Point of inflection with the graph increasing, right? Okay. Yeah, use increasing. I guess that's fine too, but there it is. So what are my two choices? 3 or 31. So use one of those two. So here we go. Y equals 5 sine, everything else is the same, 90 over 7, X minus 3 degrees, close, plus 8. So you already know what I'm going to do. I'm going to graph it. Go to my calculator, go to Y3, 5 sine, alpha Y equals, enter, 90 over 7, X minus 3, close, plus 8. This color is going to be black, graph. And look at that. Cool, right? Super cool. All right, don't worry, we're almost done. All right, so on this one, all right, first let's talk about what this even means, because I think sometimes you guys get confused. It wants cosine with a negative vertical dilation. What does that mean? A negative in the front. There's no such thing as negative amplitude, but they're saying that you want a negative in the front. Cool? All right, so put your pencils down for a little bit, because I want to make sure that you guys really understand this part right here. So put your pencils down. I don't want to see any more pens or pencils, just for a little bit. So I'm going to draw another graph. Chop. Why? Wherever I have max, I'm going to put mins. Wherever I have mins, I'm going to put max. We're going to use your skills from last year. So don't write this down in a little bit. I'll give you guys time to write this down and put the thoughts, put your logic of what we did. Wherever I have a min, I put a max. Wherever I have a max, I put a min, and I highlighted the points of inflection. I'm doing this graph in blue. Do you guys see that graph in blue there? Okay. If I were to ask you, give me the graph in blue, and I want you to use cosine, you would say, okay, well, I have a peak here at 24 degrees, and I'm using cosine. So y equals, and then you would say everything's the same. The frequency's the same, the amplitude's the same, like everything's the same. So you would go y equals 5 cosine 90 over 7 x. Where's my peak at for the one in blue? X minus 24 degrees, close, plus 8. So don't write this down, just listen. Are we okay so far? Now, notice, that's the one in blue. If I put a negative in the front, it's the same transformation from your algebra 2 days. If I put a negative in the front, the maximum becomes minimum, because that's across the x-axis, but remember, now we did a shift. So your max becomes mins, and your mins become max. Does that make sense? Yes. So, you're not going to put a negative here, because that would turn that blue to that green. You're going to put a negative on this one. See, because that one says negative, right? So you're going to go y equals, it's this graph, but I don't want the blue one, I want the green one. When I put a negative in front of that 5, that blue graph will turn into that green one. You guys just told me that, right? Max becomes mins becomes max. So I go negative 5 cosine 90 over 7 x minus 24 degrees, close, plus 8. And there it is. That's my graph. Let me zoom out so you guys can write. And then put the ideas of what we just talked about right now. Make sure you draw the blue graph. Put the ideas. Find that in cosine. And then put y. Mins are negative. Max becomes mins becomes max. You already know what I'm going to do next. What am I going to do next? Type it into my what? Calculator. Get your calculator out. Go to the next one. Y equals, and look, I'm just keep filling it in. Negative 5 cosine alpha y equals, enter, 90 over 7. Yeah, make sure, try it out, guys. Try it out. X minus, what was it again? 24? Was it 24? Yeah, 24. X minus 24. No, I did. Plus 8. I'm going to push graph. Let me see. What color do you want to call this? Pink? Boop. Look at that. Same graph over and over again. Don't worry. I'll show you how to look at it when you have just a general black and white calculator. All right. Yay or nay? Okay. Now you guys can come and follow along. We're still with the same. It says letter D says sine with a negative vertical dilation factor. Okay, I'm going to come back. What if I told you I want this blue curve, but I want it in sine? Y equals 5 sine 90 over 7 parenthesis, and I got to pick a point of inflection going up on the blue curve. So what point of inflection going up do you see? 17. X minus 17 degrees, close, plus 8. Don't put a negative there, because then you're telling me that graph is negative. You're going to put a negative where they want it, down here. Sign with a negative. So if I put a negative in front of that 5, then my max becomes min, my min becomes max. Yes or no? Yeah, that blue one turns into the green one again. So negative 5 sine 90 over 7, x minus 17 degrees, close, plus 8. There it is. I'll zoom out so you guys can see the graph. And you already know what I'm going to do. I'm going to type it into my calculator. So I'll take my little calculator. Man, look, I have 5 equations in here. Negative 5 sine alpha y equals, enter, 90 over 7, open, x minus, and I already forgot again, what was it? 17, okay, I believe you guys. Close, enter, enter, plus 8. This one's green, let's see, graph. Look at that. Okay, Chav, but I don't have a color calculator. How am I going to see all these? You can see a table. See, it says table. So you push second table, and look at all those numbers. They're all the same. Look, I'm going to go to 3 because I have a nice integer at 3. At 3, they're all 8. Look at that. 8, 8, 8, 8, 8. 8 sounds like 8, and we cooked today, and we just ate what we cooked. So, okay, I'll stop. All right. There you go, guys. Notice if you're notice all these transformations you already knew from years past. We're just using them again now with sinusoids. Cool or not cool? Yeah. All right, guys. So we're done for today. Did we cook today?